Professor Hans, thank you very much for the short introduction. Yeah, welcome to my presentation. It's a technical report on the development of an autonomous strawberry harvesting robot. I'm not Steffen Lack, like it's written in the program, so unfortunately he is not available today. I'm Christian Steinbrecher from the University of Wismar, and I will present the work of my PhD student of Steffen Lack. So at first I will give you a short overview of my presentation. I will explain you the motivation, the conditions, and the difficulties in harvesting strawberries. Then I will explain the different components of an autonomous strawberry harvesting robot, which we need. I will show you some tests and results and some small movies, and at the end I will give you a short conclusion and an outlook. So at first, the motivation. There's an increasing lack of seasonal and skilled laborers, especially in regions with less than aging population. Manual harvesting is very costly, especially by fruits and vegetables that requires the selective picking. You can only harvest strawberries one by one. You can't harvest strawberries, more than one strawberries at once. So that makes it very costly. And fruits and vegetables must be harvested in a narrow time window to ensure freshness, quality, and shelf life. And of course, there's a growing demand for increasing the efficiency and the sustainability in agriculture, especially because of the growing global food demand and as well of climate changes and climate conditions. So, and of course, unlike a human labor, robots can work continuously, regardless time and weather, of course, with some limits, and that increases the productivity. So, but it's not so easy to develop autonomous strawberry harvesting robot because there are some difficulties. Yeah? Strawberries are a very special culture. Strawberries are very delicate and sensitive to pressure. Not all ripe strawberries have the same color. For example, because of varying lighting, because of shadows or sunlight, it's hard to detect the difference between a ripe or unripe strawberry by the cameras and sensors. The strawberries can be partial or completely hidden from cameras and sensors by leaves or other strawberries. And of course, there's a big variation of the type of strawberries and also of the growing system of the strawberries. Here are these three pictures that are three different growing systems for strawberries. The first one is the strawberries are planted at the ground. And the second picture shows the strawberries planted at such raised beds. And the last growing system, it's the third picture, there are the strawberries planted in such racks 1 meter above the ground. So that makes it difficult for one robot or autonomous system to harvest strawberries. And of course, weather, mud, uneven terrain are also challenges for a field robot too. And rain, dust, for example, can impair the cameras and sensors. So it's very difficult to build an autonomous strawberry harvesting robot. But we tried it. And we built, or Steffen built, a prototype of a strawberry harvesting robot. And now I would like to show you the different components we need for such a system. The key focus of our realization was to realize it very cheap. Yeah? So at first, of course, what we need is a mobile platform. Yeah? So we developed different mobile platforms and different prototypes. For example, with a 4-wheeled platform or a 3-wheeled platform. Also, we developed a prototype with a chain drive. So different designs we developed and we tested it also. So at the end, for example, for strawberries that are planted in such racks 1 meter above the ground, we used a 3-wheeled mobile platform. And at the end, it's only the platform. There isn't any robot on it, but the robot and the robot kinematic will be placed somewhere here. Yeah, I will show it later in some short movies. So you have a mobile platform now, and this mobile platform drive safely through the strawberry lanes. And of course, what we need is the robot kinematic. So the robot kinematic, for that we also develop different approaches, different concepts. And here we found that it's better to develop different robot kinematics depending on the growing system of the strawberry. So it's better to use one robot special for strawberries planted at the ground and one robot kinematic special for strawberries planted in such racks. Yeah. So for example, for strawberries planted in such racks, we use the 4-axis robot kinematic like it's shown here. Yeah. So that's the robot kinematic. And another very important part of our strawberry harvesting robot is the gripper. Yeah, we can harvest strawberries with our hands, one by one, for example, but the robot has also to do it. So that's why we develop different grippers. For example, the scissor gripper here, it's a special scissor gripper. The scissor gripper is cutting the strawberry at the stem, and then the scissor, after cutting, the scissor gripper is fixing the strawberry to put it with the scissor gripper into a box. Yeah. And the same as with the hook gripper. Here you see the hook, and here in this picture you can see the strawberry in the black circle with the stem. And when this hook is moving a little bit backwards, the strawberry will be fixed here. And when the hook is moving a little bit more backwards, then the stem will be cutted on this small knife marked with number 4. So there's a knife, that's why the stem will be cutted and as well fixed on the hook, and then you can put the strawberry into a box with the hook gripper. Another gripper we developed is the finger gripper. Here you see a vacuum source here and here, and with the vacuum source we fix the strawberry. Then the fingers are enclosed the strawberry and the fingers are rotating, and that here's the stem. Yeah. So I will show it later in a short movie. So that's our grippers. And of course, if you want to have an autonomous strawberry harvesting robot, you need a camera system and an image processing. So that's why our scissor gripper or scissors gripper, for example, or the other grippers or have camera system. For example, here for the scissor gripper, you see the camera here. And with the camera system, we detect the ripe strawberries. For that, we trained a neural network. And that neural network provides us the ripe strawberries, for example, the unripe strawberries, and also the stems, for example, here, corresponding to the ripe strawberries. Yeah? Because the scissor gripper and the hook gripper harvest the strawberry at the stem. So we have to detect the stem of the ripe strawberries. And the finger gripper is harvesting the strawberry directly. So in this picture here, you see a special picture for the finger gripper because the finger gripper is harvesting the strawberries from below and not from the side, like the scissor and the hook gripper. So that's why we need a picture from below. That is a picture from the side of the same strawberries, like here, from the side and from below. For example, this strawberry here, the picture from the side is hidden by this unripe strawberry, but from below you can see this ripe strawberry very good, and so you can harvest the strawberry from below very, very easily. So that's our camera system and our image processing. And of course, for a robot, we need a control system. For that, we developed 2 control systems, one for the mobile platform and one for the robot. So it's similar, I think. We have some hardware drivers for the motors, for example, and for the drive. Also a controller, it's the STM32 for the hardware driver, and a small computer for communication, for the navigation, for example, and also with a small display to have some user interface or user interactions. So, and for the robot, we use the 4-axis robot, and so we need 4 stepper motors with 4 hardware drivers, and as well we need some drivers for the grippers and also some voltage supplies for the sensors. So for that, we also need some hardware drivers, and we have also implemented the Raspberry Pi as a small computer for user interface and also for communication. So the neural network isn't calculating on the Raspberry Pi. The neural network is calculated at a server because it's a little bit faster. So, and all these components together results in our strawberry harvesting robot. It's called Einstein. I don't know exactly why it's called Einstein, but Steffen and Peter do know called it. And this strawberry harvesting robot moves now safely through the strawberry lanes, and hopefully you will harvest some and pick some strawberries. So for that, I will show you some pictures, some results. Here you see our strawberry test bench. Yeah, here you see a scissor gripper is a special scissor gripper. They won't cut the strawberry at the stem because these strawberries are fixed with a magnet to dry it again. Yeah. So he makes a picture, then the image processing is working, and then you will harvest the strawberry. So here it was a very early test. There wasn't a strawberry. So, but in the next try he will get the strawberry. So that's just a test bench, just a try. And here you see the scissor gripper in real life. So the gripper is moving directly from the camera position to the stem, and then he will harvest the strawberry. Here we see our hook gripper. It's just a manual test. I can show you. And so the hook is moving backwards, fix the strawberry at the stem, and then it's cutted by the small knife at the hook. And here you see the hook gripper in real life. It's not a good movie because the perspective is changing very quickly. So, but at the end you see that the hook gripper is getting the strawberry and you can put it into a box, something like that. And our last gripper, you see it here, a test bench for our finger gripper. Here we have this vacuum source, and so fix the strawberry, encloses with fingers the strawberry, and then he will rotating, and that will tears the stem. So here in real life, for strawberry planted in such racks 1 meter above the ground, and he harvests the strawberry from below. Yeah, I have said. So, yeah, that are some results of the work of Steffen Lack. And yeah, okay. Now I would like to give a short conclusion and an outlook. In this study, we present our recent developments of an autonomous strawberry harvesting system. Our results demonstrate that autonomous system can be effectively applied to complex processes, and strawberry harvesting is a very complex process. And we have found that, especially with cooperation with some strawberry farmers, that the cost is the deciding factor for such a system. It must be cheap, yeah, for the farmers. So, of course, you can use the industrial robot to harvest strawberries, but it's very expensive. So that's why we developed a tailored robotic kinematic, special for the strawberries, and we used also cost-efficient standardized components like aluminum profiles, HPL plates, or 3D prints. So this makes it a little bit cheaper than as using industrial robot. Yeah, and for the outlook, of course, we can increase the efficiency through improved image processing and motion planning, and as well, it would be nice to try our adaptation, our existing concepts to other areas, application areas, for example, for harvesting some tomatoes or peppers or something like that. Yeah. So, okay. I'm now at the end. Thank you for your attention. And is there any questions?